NASA is worried. Something is happening to the Earth's magnetic field between South America and Southwest Africa. An anomaly is causing a strange dent in the magnetic field there, and it's growing. What should we expect if the South Atlantic Anomaly continues to grow, and what is the reason for this hole? Stay tuned and sit back as we explore one of the most explosive questions in Earth geology. Why NASA? Now, right at the outset, you may be asking yourself why NASA, of all space agencies, is responsible for a geological feature on Earth. The answer to this question is easy. The anomaly in the Earth's magnetic field has an effect all the way into the cosmos and can cause massive disturbances and damage to satellites there. NASA and other space agencies must therefore take precautions to protect their satellites or even spacecraft from the effects of this anomaly. The Earth's magnetic field is a protective shield that extends far into space and deflects, among other things, high-energy particles emitted by the sun. The field is created by the structure and elements in the Earth's core, the Earth's rotational speed, and other factors such as precession. Strictly speaking, the origin of the Earth's magnetic field resembles a gigantic geodynamo process, which produces a finely tuned, perfect field, which not only serves to protect, but also promotes life of this Earth in a special way. It is by far not self-evident that a planet has a magnetic field like ours. Our neighbor Mars, for example, has only a very weakly developed magnetic field and is thus exposed to the particle bombardment from the sun and cosmic radiation almost unprotected. Experts even suspect that it was this weak magnetic field that prevented Mars from turning into a thriving world like ours, and that Mars became increasingly desolate over the millions of years. In the case of Mars, it is probably the composition of the thoroughly liquid core that is responsible for the magnetic field being only very weak. Our Earth has a solid core of iron and nickel with a liquid mantle around it, and also otherwise amazingly perfect conditions for the formation of a strong magnetic field. To generate a magnetic field through the geodynamo process, a planet must meet certain criteria. It must be spinning fast, have a conductive fluid in its interior, and have an internal energy source capable of driving convection currents within the liquid core. Fortunately, the Earth meets all of these conditions. The ocean of molten iron inside the Earth is just perfect and generates electric currents due to the Earth's rotation, which then form the Earth's magnetic field. This field induces further electric currents, which generate additional magnetic fields, creating a self-sustaining loop of electric currents and magnetic fields. The magnetic field generated in this way is not always uniform, but resembles a living dynamic process. The biggest dent in the magnetic field. Over the Atlantic Ocean, this magnetic field has a huge hole. The reason for the large anomaly is a huge reservoir of dense rock, which scientists gave the impressive name African Large Low Shear Velocity Province. You could also call them Large Low Shear Velocity Provinces, or LLSVPs for short. These areas are massive structures deep in the Earth's mantle that can stretch for thousands of kilometers. Their name derives from the fact that seismic waves, especially shear waves, travel more slowly through these regions than through the surrounding mantle material. This is due in equal parts to the composition of the rock layers and to changing temperatures within the Earth. To fully understand the massive impact of LLSVPs, we need to imagine the Earth for a moment as a layered sphere. The core at the center is surrounded by a mantle of hot, semi-solid rock that moves very slowly. Surrounding this mantle is a solid crust. Seismic waves generated by earthquakes or other events travel through these layers, thereby providing scientists with valuable information about the Earth's interior. LLSVPs are located at the bottom of the mantle, near the boundary with the Earth's outer core. One particularly large structure exists between Africa and another beneath the Pacific Ocean. Both structures are so massive that they affect the movement of material in the mantle and processes such as mantle convection and plate tectonics. The African LLSVP is nearly 10 million years old and extends for thousands of kilometers. Scientists suspect that the structure between the hot liquid iron of the Earth's outer core and the stiffer, cooler mantle can disrupt the movement of molten iron. It is precisely this molten iron that creates the Earth's magnetic field through vibration and motion. By blocking it, the South Atlantic Anomaly creates a considerable dent in the Earth's magnetic field. The anomaly became known through measurements of seismic waves in the Earth's interior. The scans showed significant changes in their direction of motion in these regions. The images created by the movement of the waves in the Earth's interior resemble an X-ray image of the inner layers of the Earth. As early as the 19th century, the famous naturalist Alexander von Humboldt observed the reduced strength of the Earth's magnetic field over the southern Atlantic Ocean. Since then, the anomaly has been the focus of extensive study, and the implications of this phenomenon can be fascinating and frightening in equal measure. The significance of the Earth's magnetic field. To understand the possible effects of the anomaly, we need to know the effects and tasks of the Earth's magnetic field. In addition to protecting the entire globe, the Earth's magnetic field accompanies us constantly, without us noticing it in any particular way. An impressive natural phenomenon directly related to our magnetic field, which almost all of us have seen in photos or in real life, are the polar northern and southern lights. These bright green or violent celestial phenomena are the result of interactions between charged particles and our magnetosphere. Today, it is known that many animals use the magnetic field as an aid to navigation. Migratory birds and sea turtles navigate along invisible magnetic routes, as do hikers or navigators using a compass. Presumably, our bodies are also aligned with this field in some way. Although research on this topic is currently in its infancy, what is known is that there are people who perceive this field and even disturbances such as those caused by solar winds. Our inner clock very probably works in coordination with the field, and nowadays researchers suspect that the many artificial magnetic fields caused by cell phones and company could disturb our natural magnetism and promote diseases. Since the anomaly over the South Atlantic has existed for a very long time, we living beings in this world have been living with it for a very long time. For example, animals in South America or South Africa have never been observed to show abnormalities due to the anomaly. The anomaly is so normal that life has adapted to it. The anomaly could become dangerous for our technical facilities. But before we take a closer look at this danger, let's take a trip into the Earth's protective shield. Solar protective shield. When solar particle streams hit Earth's magnetosphere, they are trapped in two donut-shaped belts around the planet. Astronomers call this belt the Van Allen belt. Within the belt, the high-energy particles are forced to travel along Earth's magnetic field lines about 645 kilometers from the surface. In the process, they bounce back and forth between the poles but do not reach the Earth. The particles are inside the belt, like in a bottle. The exact processes in the Van Allen belt are a complex process in which the particles from space are exposed to various influences and changes. As they bounce back and forth between the poles, their dynamics change. Some may interact with the atmosphere and be lost, while others are scattered and driven out of the belt by interactions with plasma waves in the belt. Incidentally, it's precisely these solar particles that cause the night sky above the poles to glow with the wonderful colors of the northern or southern lights at certain times. Only at particularly intensive solar activities, the solar particles bound in the Van Allen belt become highly energetic, whereby it comes to rare deformations of the magnetic field, and nevertheless, some particles can penetrate into the atmosphere. Then, there is also a significant expansion of the South Atlantic Anomaly, and the dent in the magnetic field stretches. The anomaly grows and migrates. A 2016 study surprised with the result that the South Atlantic Anomaly is gradually drifting in a northwesterly direction. Recent measurements also showed that the anomaly is not only migrating, but also splitting into two parts. In 2020, satellite data from the European Space Agency showed an anomaly divided into two cells, each with a separate center of minimal magnetic intensity. These changes are not overly significant to organic life on Earth, but for satellites, spacecraft, and technical equipment, the anomaly can pose a considerable challenge. If flying objects pass through the affected regions, the devices are more susceptible to charged particles from the sun due to the weakened magnetic field. When the International Space Station flies through the anomaly region, certain instruments mounted outside the ISS regularly fail. The scientists of the Global Ecosystem Dynamics Investigation also had a similar experience. Due to the influence of the anomaly, measurement sensors mounted outside the ISS failed, and thousands of measurement data were lost. This is a warning and shows us how sensitive technical equipment is to disturbances in the magnetic field. And we are, after all, a civilization that lives with increasing mechanization. If the effects of the anomaly increase in the future, sensitive satellites in Earth orbit could be affected more frequently by failures. This would lead to communications breakdowns across the globe, and the companies that operate the satellites would face high repair and replacement costs. If the anomaly extends further, experts also fear increased radiation exposure in certain regions. The extent to which this would affect the health of humans and animals is difficult to assess at this point. Some experts suggest that the anomaly's growth may also be a sign of impending major challenges in Earth's magnetic field. Historically, there have been several magnetic field reversals in which the magnetic poles switch places. Changes in the South Atlantic Anomaly could be an early indicator of the onset of such processes. With a pole jump, where the magnetic South Pole becomes the North Pole, changes will begin on Earth that no one can estimate at the moment either. Future research. To be ready for a historic event such as a pole jump or anomaly expansion, the anomaly over the South Atlantic is constantly monitored. NASA and other space agencies monitor the anomaly's behavior from space, while geologists on Earth's surface pursue the mysteries of this feature. Since the magnetic field in our satellite-based communication systems are essential to the entire globe, air travel, or even navigation on the oceans, millions are spent annually to continue to observe and study the anomaly. What do you think? Can these measures make us feel safe? Do you think the anomaly is something natural, or is it the harbinger of a pole jump?